Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge O-Levels Mathematics Syllabus D. We also call this subject Mathematics Syllabus D, DMaths 4024. In this video, we are going to learn how to convert non-terminating recurring decimal fractions into simple fractions. This content has been added into the syllabus, and this will be assessed for the examinations which are starting from May, June 2025. So in this video, we are going to practice some questions related to this topic. So let's start, and here we go. So this syllabus content has been added into the Mathematics Syllabus D 4024, and this will be used for syllabus for the assessments which are starting from 2025. So if you look at the syllabus content, so this is the thing in which we are interested. So here you see we have decimal fractions, and which can have a dot on one digit, or they might have a dot on two digits. Or instead of putting dots, they might put a bar. For example, you can see in this example, 0.123, they put a bar on it, which means that these digits will be repeated. So for example, 0.17 on the 7, they have put a dot. So that means this 7 will be repeated again and again. And this is recurring, and it's non-terminating. So we have to learn how to convert into simple fractions. For example, here you have dots on 2 and 3. So that means that 2 and 3 will be repeated. It will reoccur. So it will be 0.1, 23, 23, 23, 23, and it will go on. For example, here you have 0.123 and a bar on it, which means this 1, 2, 3 pattern will be repeated. So it will be 0.123, 123, 123, 123, 123, and it will continue. So these are called non-terminating recurring decimal fractions, and we have to convert them into simple fractions. And this is the exact wording which the Cambridge will be using to ask you this question. Convert the given decimal fractions into simple fraction. Okay, so let's start. We have collected some questions from different sources, and we will try to solve them. So here we go. So unfortunately, this is a little lighter. Okay, so express the following decimal fractions in the form P by Q, which means a fraction where P and Q belongs from the integers and the Q is not equal to 0. For example, in this first question, we have 0.3, and on that 3, we have this bar sign, which means this is a non-terminating recurring decimal fraction. It means that these 3 will be repeated, okay? So it is like 0.333, and it continues. So how you will do this? So what I will do, I will write x equals to 0.3, and on that 3 we have bar. So this means 0.33 bar. Okay, you can write it like this. Okay, then you multiply both sides with the 10. Okay, so this side will become 10x, and when you multiply 10 with this number, so this 3.3 bar. So you see, why multiplying with the 10? You see, I just want to make this 3 bar is at the first decimal place. So I will multiply it with the 10, or I will multiply it with 100, or I can multiply it with 1000. I just want, from this decimal fraction, I want this 3 bar to be again on the first decimal place. So I choose 10. So now this is 10x is equal to 3.3 bar. So then I will, from this second equation, I will subtract this first equation. So you will have 10x minus x equals to, from the left side, I'm subtracting the left side, equals to 3.3 bar minus 0.3 bar. So when you subtract them, you are left only with the 3. 10x minus x, that is 9x. So take this 9 to the other side. So x will be equals to 3 by 9. So x will be equals to 1 by 3. So on your calculator, this has been converted into simple fraction. So if on your calculator, if you will enter 1 divided by 3 equals to, and you will get 0.3333333333. This 0.33333, that can be written as 0.3 bar, and that means that this is a non-terminating recurring decimal fraction, and this is how you convert it into the simple fraction. So that was question number 1. We practiced. Now we will have another question, and here we have the question will be convert this decimal fraction into simple fraction. So they have given you 0.23, and on that 23 we have bar. So what does this mean? This means that 23 will be recurring. So it is 0.232323, and it continues. So you can say let x is equal to 0.23 bar. So what you will do, you will take one of this pair, and then on the next pair you write the bar. So x will be equal to 0.23 and 23 bar. So now I will multiply it with the 10, or I will multiply it with the 100, or I can multiply it with 1000. So how I decide that with which number I should multiply? I will multiply it with the 10 or 100 or 1000, in keeping in mind that this 2, 3, this is on the second and the third, sorry, it is on the first and the third decimal place. So I will multiply this in such a way that this should come on the first and second decimal place. So I am multiplying both sides with the 100. So 100x is equals to 100 multiplied with this. So 100x will be equals to, so you see this 2 and 3 will be 23.23 bar. So now you see this 2, 3, which has a bar on it, is on the first and second decimal place. And here it is also on the first and second decimal place. Now from this second, I will subtract the first one. So we will have from the left side will be subtracted. From the right side will be subtracted. So it will be 100x minus x, and that will be equals to 23.23. And on this 23, we have this bar, or we can have two dots here, minus 0.23 bar. So when you subtract them, you get 23. 100 minus x, that's 99x, and that will be equals to 99x equals to 23. So x will be equals to 23 divided by 99. So you see, we have converted that non-terminating recurring decimal fraction into simple fraction. On your calculator, you can write 23 divided by 99, and you will get this 0.2323232323. This is the check how you can check if your answer is right. Okay, so here we have another one, and this one is okay. So this is question number, third question we have collected from different sources, and there they want me to convert 0.5, and on that 5 we have bar. So this is a non-terminating recurring decimal fraction. This bar, or sometimes they put dot on it. So that means that this 5 will be repeated again and again, and it will be non-terminating. So 0.5555555, and goes on. It goes on. So I will suppose let x is equal to 0.5 bar, and on the 5 we have this bar. So I will take 1 5, and then on the next 5 I will put the bar. So this is the trick how we do it. So now you have x equals 0.5 and 5 bar. So I will multiply it with the 10, or I can multiply it with the 100, or I can multiply it with the 1000. But with which number I will multiply, how I decide? You see here, it is this 5 bar in the original thing is on the first decimal place. So I will multiply this with 10, so that this 5 bar will also come on the first decimal place. So I multiply both sides with the 10. So you will have 10x is equals to 10 multiplied 0.55 bar. So it will become 10x is equals to 5.5 bar. This means 5 will be repeated. So from this second, I will subtract this first one. So you will have 10x minus x equals to 5.5 bar minus 0.5 bar. So you will be left with the 5 only. So 10x minus x, that is 9x. So that is x will be equals to 5 by 9. So on your calculator, you can do 5 divided by 9 and you will get 0.555555555. So this is how you will convert this decimal fraction into simple fraction. And you know, this non-terminating recurring decimal fractions, they are called rational numbers. They are not called irrational, they are called rational numbers. Okay, so any decimal fraction which is non-terminating and is recurring, that is called rational. Okay, so here we have the fourth question. We have collected these questions from different sources. So we are going to do this, attempt this question number 4 now. Okay, so here we have 0.13, and on that 13 we have this bar. Okay, so this bar, or if sometimes what they do, they put dots on 1 and 3. So that means this 1 and 3 will be recurring. It will be repeated. So that means 0.131313131313, and it goes on. So what I will do, I will suppose that x is equals to 0.13, and on 13 we have this bar. So one of the pairs I will separate it, and on the next pair I will write 13 bar. So now I will multiply it either with the 10 or with the 100 or with the 1000. So how I decide? You see here, the 1 and 3 which are going to reoccur, and they are on the first and the second decimal place. So I will multiply it with such a way that this after multiplication should become on the first and the second decimal place. So I'm going to multiply it with the 100. So 100x is equals to 100 multiplied 0.13, and on this next one we have a bar. So this will become 13.13 bar. This is 100x. So from this second, I will subtract this first equation. So from 100x, the x will be subtracted from 13.13, and on that 13 we have bar minus 0.13 bar. So you will have this situation, 100x minus 13.13 bar minus 0.13 bar, and this is 99x, and this is 13. So x will be equals to 13 divided by 99. So you see, we have converted that non-terminating recurring decimal fraction into a simple fraction. So this is a rational number. Any decimal fraction which is non-terminating recurring is called rational. Okay, so you converted that rational fraction into a simple fraction. I hope you understand. In your calculator, if you will enter 13 divided by 99, you will get 0.13131313131313, and it will continue. Okay, so we are going to the next another example related with this topic, and here we have question number 5. Okay, so here we go. Let me bring it. Okay, now we have 0.67, or on that 67 we have this bar sign. We can have two dots on top of them. They both mean the same thing. That means that this 6.67. So this 67 will be recurring. So it will be 0.676767676767. It will continue. So let x is equal to 0.67, and on that 67 we have a bar sign. So x will be equal to 0. I will take out one of these pairs. So I will write 0.67, and on the next 67 I will put the bar. This means this will continue. So now I have to multiply. I will multiply either with the 10 or 100 or 1000. How I decide? You see here, this 6, 7, which are going to reoccur. They are on the first and second decimal place. So I want to bring this also on the first and the second decimal place. So for this purpose, I will have to bring this to the this side of the decimal. So I'm going to multiply both sides with the 100. So I will multiply both sides with the 100. So you will have 100x equals to 100 multiplied 0.67. And on the next 67, we have this bar sign. So 100x will be equals to 67.67. On this 67, we have this bar sign. So from this second equation, I will subtract this first equation. So you will have 100x and minus x. The left side will be subtracted from the left side, and the right side will be subtracted from the right side. So 100x minus x is equals to 67.67 bar minus 0.67 bar. So you will have 99x equals to 67. So x will be equals to 67 divided by 99. So in your calculator, if you will enter 67 divided by 99, you will get 0.676767676767. That 67 will be non-terminating recurring. So this is how this is done. This is how you do it. This is question number. This is the fifth question which we have done on this topic. So I hope you understand. Let's do the next one. Okay, so here we go. Okay, so here we have 0.419. So on that 19, we have the bar sign. So that means that this 19 will be reoccurring. It will come again and again. So it is like 0.419191919191919. So let x is equal to 0.419. On this 19, we have these dots, you can say, or we have bar on them. So I will get this pair free. So I will write it x equals 0.419, and on the next 19 I put this bar sign. Now I want to get rid of this. So you can see that this 19 is on the second and the third decimal place. So I will multiply here with the 10, 100 or 1000 in such a way that I will bring this 19, which has a bar on it, on the second and the third place, third decimal place, I mean. So multiply both sides with the 100. So you get 100x is equals to 100 multiplied 0.419. And on the next 19, we have a bar sign. So 100x will be equals to 41.9 and 19. And on this 19, we have this bar sign. So from this second equation, we will subtract this first equation. So you will have 100x minus x equals to 41.919. And on this we have bar minus 0.419. On this 19 we have bar. So when you subtract them, here you will have 99x equals to, here you will have 41.5. So x will be equals to 41.5 divided by 99. So when you remove this decimal, you have to put, so this is 0.5. So when you remove this decimal, here you have put a 10. So this will become 415 divided by 990. So 415 divided by 990. So if you enter this in your calculator, you will get 0.419191919. So you know this fraction can be further simplified. So 415 divided by 990, this can be further simplified with the 5. So this will become 83 divided by 198. If you enter 83 divided by 198 into your calculator, you will get 0.4191919. I hope you understand this sixth example. So you see, in this we converted a non-terminating reoccurring decimal fraction into a simple fraction. Okay, so let's go to the next example, and that is example number 7. Here we have 0.312. And on this 12, we have put two dots. These two dots, or sometimes they put a bar on them. This means that this 12 will be reoccurring. So it means 0.31212121212, and it continues. So we have to convert this into simple fraction. So let me say x is equal to 0.3 and 1, 2, and on this 1, 2, we have these two dots, which means that they are reoccurring. So x is equals to, I will get this one pair free of these dots. So I can write it 0.312, and on the next 1, 2, I put these dots, okay? Now, this 1, 2 reoccurring portion, that is on the second and the third decimal place. So I want to bring this also this one on the second and the third decimal place. So for that purpose, I'm going to multiply both the sides with the 100. So 100x is equals to 100 multiplied 0.312, and on this 1, 2, we have these dots, or you can say we have bar. So when you multiply with the 100, you will get 100x is equals to 31.212 bar. So you can see this 1, 2, which has a bar on it, and this 1, 2, which has a bar on it. They both are on the second and the third decimal place right now. So from this second, I will subtract this first one. So you will have 100x minus x is equals to 31.212. On this 1, 2, we have bar minus 0.312, and on this 1, 2, we have this bar. So when you subtract them, 99x is equals to 30.9. So x is equals to 30.9 divided by 99. So I will remove this decimal. For that, I will put 10 in the denominator. So you will have 309 divided by 99 into 10 in the denominator, you know. And so this is 309 divided by 990. This can be also further simplified. So if you want to simplify, it will become with the 3, you can say 103 divided by 330. So either you write this in this form, but if they in the question they ask you write this, convert this into the simplest form, then please convert it into the simplest form. This can be further simplified with the 3. So if you in your calculator, if you will enter 309 divided by 990, you will get 0.31212121212. So this is how you convert this non-terminating recurring decimal fraction into simple fraction. I hope you understand. So here we have another question, question number 10, question number 8. And here you have write the 0.23. On that 3, we have this dot. They might put a dot there, or they might put a bar on the 3, which means that 3 will be reoccurring. So that means this fraction is 0.33333333. So this is x equals to, let me say x is equals to 0.23, and on that 3 we have dot, and this is on the second decimal place. So this can be written as 0.23 and 3, and on that second 3 I put a dot. So now I'm going to multiply both the sides with the 10. How I decided to multiply with the 10? Because here this is on the second decimal place. So I want this 3 bar also on the second decimal place. So I'm going to multiply it with the 10. So 10x is equals to 10 multiplied 0.233 bar. So it will be 10x equals to 2.3, and on that 3 you can put a dot or a bar. So from this second, I will subtract this first one. So from the left side will be subtracted from the right side will be subtracted. So you will have 10x minus x equals to 2.33 bar minus 0.23 bar. So you will have 9x equals to 2.1. So x will be equals to 2.1 divided by 9. So when you remove this decimal in the numerator, you will put a 10 in the denominator. So you will have 21 by 90. If you enter 21 by 90 in your calculator, you will get 0.23333333. You can further simplify this with the table of 3, so that 21 by 90 will become 7 by 30. If you enter 7 by 30 in your calculator, you will get 0.23333333, and 3 continues. So this is how you convert this non-terminating, reoccurring decimal fraction into a simple fraction. Okay. You know that the non-terminating reoccurring decimal fractions are called irrational. Okay. So they are irrational. Okay, they are not sorry, I said irrational. They are rational. They are not considered irrational. Okay, so question number 9, another question which we have collected from different sources, and just to give you some practice on this topic. So write 0.38, and on that 8 we have a dot sign as a fraction in its simplest form. So that let me say that x is equal to 0.38, and on that 8 we have a dot, or you can say a bar, which means that this will be reoccurring. Reoccurring means it is 0.38888888. Okay, so I will get one of this pattern, that I will get it freed from the bar. So x is equal to 0.38 and 8 bar. This is on the second decimal fraction, so I will multiply this with the 10 or 100 or 1000 in such a way that this 8 bar should also come on the second decimal place. So I'm going to multiply it with the 10 on both the sides. So multiply both sides with the 10. You will have 10x is equals to 10 bracket 0.388 bar. So it will become 10x equals to 3.8. And on the next 8, we have this bar. Now you can see this 8 bar is on the second decimal place. Here also the 8 bar is on the second decimal place. They are good. So from the second, I will subtract the first one. So 10x minus x is equal to 3.88 bar minus 0.38 bar. So when you subtract them, this 8 bar will be cancelled. So you will have 3.8 minus 0.3. So you will 3.5. So 9x is equals to 3.5. So x will be equals to 3.5 divided by 9. So you have a decimal in your numerator. To remove that after decimal, you have just one digit. So what I will do, I will in the denominator, I will write 10. So you will have 35 divided by 90. So in your calculator, if you will enter, 35 divided by 90, you will get 0.388888888. Non-terminating reoccurring decimal fraction. Okay, so 35 and 90, they can be further simplified with the table of 5. So it will be 7 by 18. So if you enter 7 divided by 18 in your calculator, you will get 0.3888888. That 8 is non-terminating reoccurring. This fraction is called non-terminating reoccurring decimal fraction. And we have learned how to convert this into a simple fraction. This is the brand new content which has been added into the syllabus of the Cambridge O-Levels Mathematics Syllabus D. And we have very few questions because these questions are not in your past paper. So no matter how much you have practiced your past papers, you will not get this topic in your past papers. So these are 9 questions which I collected from IGCSE, from 9 metric mathematics book, and some questions were published by the Cambridge also. And we have given you these questions so you can practice. I hope that this video will be very helpful to you. And this syllabus, the new content which has been added into the syllabus, this will be assessed in the exams which are starting from May, June 2025. And this is that syllabus content which has been added. This is the new syllabus content added. And we are 100% sure that this is coming in your paper 1. 2 marks or 3 marks question, 100% sure that this is coming in the paper. So please practice these questions. And at the end, I want to give credit that the syllabus content which we have used here, that is the property of the Cambridge Assessment International Education. These 2 documents which I am showing on my screen, they are the property of the Cambridge Assessment International Education. I have just downloaded these 2 documents from their website. I'm just using in this video. These documents are the property of the Cambridge CAIE. So I hope that this video will be helpful to you and you will be able to master this concept. If you think that this video is useful, please share the link of this video with your class fellows, with your junior students, or with your senior students, with your teachers. Share the link of this video on your Google Classroom, on your WhatsApp, in your WhatsApp groups, on your Facebook, on your Twitter, on your Instagram, on your Snapchat, on your TikTok. You see, when you share the link of this video, this provides support to my channel, and your support is very, very important for me. If you support me, I will be able to do this work for the students. So thank you very much, everyone. Have a good day, and God bless you all.